MRI machines produce images by detecting radio frequency signals from hydrogen protons in your body. To build a spatial map of where those signals come from, the scanner rapidly switches magnetic field gradients on and off, thousands of times per scan. Every time a gradient switches on, the coil carrying the current experiences a physical force. That force makes the coil move. That movement is the noise. The physics: MRI scanners generate a powerful static magnetic field, typically 1.5 or 3 Tesla, using superconducting electromagnets. Inside this field, gradient coils are layered copper windings arranged in 3 orthogonal orientations, covering the bore of the scanner. During imaging, the scanner's computer switches current through these coils in rapid pulses to create linearly varying magnetic fields across the patient. These gradient fields allow the scanner to spatially encode which protons are resonating at which location. The critical point: each gradient coil is a current-carrying conductor inside a powerful magnetic field. The Lorentz force law, F equals I times L cross B, states that a current-carrying wire in a magnetic field experiences a mechanical force proportional to the current, the length of wire, and the magnetic field strength. When the gradient switches on, the coil experiences this force and physically deflects, expanding, contracting, or twisting depending on orientation. When the gradient switches off, the force disappears and the coil snaps back. This happens hundreds to thousands of times per second during a scan sequence. The rapid mechanical deflection of the coil vibrates the air and the scanner housing, producing the characteristic knocking and banging. The frequency matches the switching rate. Frequencies in the 1 to 10 kHz range, well within the human hearing range. Higher field strength means stronger Lorentz force and louder noise. 3 Tesla scanners are measurably louder than 1.5 Tesla scanners. MRI noise peaks at up to 130 decibels during certain scan sequences, the same noise level as a jet engine at 100 feet. This is why MRI hearing protection is legally required in most countries. The noise is not a side effect of the electronics. It is the gradient coils physically slamming against the magnetic field thousands of times per minute. Silent MRI technology, such as GE Silent Scan, does not remove the Lorentz force. It changes the shape of the gradient switching waveform. Instead of switching current on and off as a sharp square pulse, which delivers the force as a single sharp impulse, it uses a smoothly shaped waveform that delivers the same total force over a longer time. The peak deflection of the coil is much smaller, even though the total work done is the same. The result is a scan that sounds like a quiet hum instead of a jackhammer. Same physics, reshaped impulse. The MRI machine is not malfunctioning. It is not poorly insulated. It is electromagnetically punching its own coils thousands of times per minute, and you are lying inside it while it does.